Okay, so in this video, I'd like to go over how to predict and write formulas for both synthesis reactions and decomposition reactions. Okay, synthesis reactions are fairly easy to spot because you're going to have two reactants, and each of them is just going to be an element. All right, I'll do two examples for this. The first one is magnesium and oxygen gas. In all of the reactions that you're going to be asked to predict, I always recommend that people go through 3 steps when they're doing this. I find that people make fewer mistakes if they do everything in a stepwise manner rather than trying to go straight to the correct answer. All right, and those steps are going to be first to write the products as their names. All right, when I say name, I would be talking about something like sodium chloride as opposed to NaCl. All right, second thing is to then convert those names into formulas. All right, this would be the step where you turn sodium chloride into NaCl, for example. And the last step is going to be to balance the resulting equation. All right, so in the first example here, magnesium and oxygen gas. All right, we are going to, so as the procedure points out, the first thing that we want to do is to write the names, the product as names. All right, so this is going to be a synthesis reaction. All right, notice that we have a single element here and a single element here. All right, so this is going to make the compound, which is the combination of magnesium and oxygen, and that is going to be magnesium oxide. All right, that's an ionic compound. All right, the hint for that being an ionic compound is that this is a metal and oxygen is a non-metal, so it's going to make magnesium oxide. All right, the second thing that you're going to do is we're going to take all of these names right here and we're going to convert them into formulas. All right, and a couple things to look out for here is to remember the Brinkelhoff elements versus the non-Brinkelhoff elements. All right, and the Brinkelhoff elements, if you recall, are all of those elements on the periodic table that when you have them in their pure form would exist as a pair of elements. All right, and I'll point those out when we get to them. The crisscross rule, when you have an ionic compound like this, remember you have to use the crisscross rule to figure out the formula. All right, so turning these into formula. All right, so magnesium. All right, would its formula just be plain old Mg? All right, well, the answer to that comes into whether or not it's a Brinkelhoff element. All right, and notice that Mg is not one of these elements right here. All right, we then want to convert the next thing, oxygen gas, and notice that oxygen is one of the Brinkelhoff elements. All right, so when you have oxygen in its pure elemental form, it exists as O2. All right, magnesium chloride. Remember that magnesium is, in that formula, is going to be a positively 2 charged ion. Oxide is going to be a negative 2 charged ion. If you crisscross those, you would get Mg2O2, and that's going to simplify to just plain old MgO. Next, we want to balance this resulting equation. All right, so after we write the formulas down, remember it's not necessarily balanced yet. All right, so the first thing that we would want to do is recognize that we don't have enough oxygens over here. So this is going to be 2 MgOs. And then we need to have 2 magnesiums on this side right here. All right. In the next example, we're going to show calcium combining with iodine. All right, again, we have 2 just single elements, and they're going to come together, and it would be rational to assume that they just make an ionic compound between this metal and this non-metal. All right, so that the name of that is going to be calcium iodide. All right, so that's going to be the first step right here to write that the products as names. All right, we now want to turn these into formulas. All right, so calcium is not a Brinkelhoff element, so it's just plain old calcium. All right, and by the way, none of the metals are going to be Brinkelhoff. So if you know that it's a metal, you know that you can just write down the element symbol right there. All right, iodine is a Brinkelhoff element, so that's going to exist as I2. All right, and then we need to figure out what the formula for calcium iodide is. All right, so calcium is +2. Iodine makes I- as an ion. Crisscross those, and we get CaI2. All right, so the formula is going to be CaI2. All right, and the next thing that we need to do is to balance this. And if you look at this right here, you can see that you have the same number of atoms on both sides. All right, so you would have the option, it would be perfectly, so even though it would be perfectly acceptable to leave it like this, on a test in this unit, you would be expected to put ones in front of each of these to indicate that you were aware that the balanced equation were ones in each of the places. So for decomposition reactions, we're just going to do this process in reverse. We're going to look at something that has two elements in it, a compound that has two elements, and we're going to break this apart into its individual elements. So writing these as names, you would have magnesium plus chlorine. Chlorine. And notice, even though the compound is magnesium chloride, when you write chlorine as an element, it's chlorine. All right, chloride is, remember, that's what you do to its name when it's part of an ionic compound. All right, so turning these into their formulas, magnesium chloride, applying the crisscross rule, we would get MgCl2, and that's going to make magnesium, which is Mg, plus chlorine. And notice that chlorine is a part of the Brinkelhoff element name, and so therefore it has a 2 after it. Okay, so to balance this, we want to look at the numbers, and you'll notice that we have the exact same numbers of atoms already on both sides. So it's already balanced, and we're just going to indicate that by putting ones in front of each of those. All right, one last example, lead 4 sulfide. Okay. So the first thing that we're going to do is write down the names. We know that it's going to break apart and make lead, or you could write lead metal if you wanted to, plus sulfur. All right, so first we've got to figure out the formulas. All right, so again, this is this Roman numeral 4 right here. That indicates the charge on the lead in that compound. So when we're doing the crisscross rule, remember what we would do is write down the formula. Lead is Pb, all right, and it would have a +4 charge. Sulfide is going to have a -2 charge. Crisscross those, we get Pb2 S4. And remember, after we do the crisscross, we want to make sure that we simplify it to its simplest ratio. All right, so it will be PbS2. All right, we're going to convert this. That's going to break apart and make lead, which is Pb, and sulfur. And sulfur is not one of the Brinkelhoff elements, so we would just write it as S. All right, so balancing this, we look, and the only thing that we need here is that there's 2 sulfurs on this side. Right now there's only 1 on this side, so we put a 2 in front of that, and at that point it would be balanced. All right, and so if you want to, you can go ahead and add 1s in front of both of these right here. Okay, so those are examples of both synthesis and decomposition reactions. There is a practice assignment on the Canvas page, and I will be providing answers to that tomorrow. But for today, I would like you to complete that. take an image of your completed work and submit that on Canvas.